Okay, very, very good. Thank you very much for that overview, and we do look forward to volume 2 and 3 and 4. And we like the concept of taking all 3 volumes and putting it into some kind of synopsis that can be readily available and understandable to the public or people who aren't directly involved in the oil and gas business. I had one question and I want to open it other. You recognized in several places that you have some data gaps. Is there something we should be asking for, or why is that information not available, or how could it be made available so that as you complete your analysis in volumes 2 and 3, we have a better complete record? This is an oversight hearing. We want transparency and accountability. Yes. So what are we missing?
Well, I think, first of all, let me compliment you on the data that you're collecting now, which has made a huge difference in our understanding. SB4 data is just from the time that we did the BLM report to with a 6 months more of data, we see a shift in some of our understanding and ability to understand things. I think within that, we are going to have very specific recommendations about data fields that could be filled out differently or that would be more specific. And I won't try to go into too many details about that, but I'll just give you one example. If you really want to understand the correlation between the possibility of injection and seismicity, we can't just get the water records that over a month. If an operator only has to provide how much water was injected over a month, and we have a precise down to the millisecond when an earthquake occurred, we need to have data that is much more granular to understand that. So I think we're going to need that kind of data. We need probably a much better understanding of fresh water throughout the state in order to understand where it is we need to protect it. I think those are two good examples. But throughout the entire volume, you will find for every chapter a data gap section that is very extensive. So it's much too long to talk about now, but you're going to get that.
Which I can understand, but in a way it's also troubling because then we'll always have questions there. So let me open it up to other people who had specific questions of Dr. Long. Vice Chair Stone.
Push the button. Thank you, Dr. Long. I appreciate your presentation, and let's start talking about the chemicals. Most of the fracking, if you will, you said is by hydrology, water. Mm-hmm. Is there fracking that is done exclusively with water alone here, or is it always in combination with some chemicals?
Yes, I think some fracturing is done only with water. You need to keep in mind that hydraulic fracturing is not only used in oil and gas production wells, it's also used for injection wells. So a lot of and it's also used in gas storage facilities. Mm-hmm. So in cases where you intend that well to continue to be an injection well, you don't need to prop it open because the water fluid pressure will keep it open. So in some cases like that, they're only using water to frack. But in general, you need to use these additives to open up the kind of fracture that you want, carry the proppant, which is the sand that goes into the fracture to hold it open. Just one other thing is I'm not sure, as far as I know, there is some water fracking going on, but I wouldn't know that that has no additives. It's very common to be using biocides and corrosion resistors, and those are the two types of chemicals that we have the most concern about because they're highly toxic. And those are commonly used. Again, this is another situation where they're commonly used throughout the industry. It's not just being used in hydraulic fracturing. When you open up a well bore with its steel and everything else to oxygen, you have problems with biological material and corrosion taking place. And so operators in all kinds of situations are going to need to use those kind of chemicals to keep their wells functioning.
And guar gum, I noticed on one of your,
Right.
that's used as a viscosity agent?
Yes, that's a gelling agent.
And that's commonly used in San Joaquin
I think
Valley?
that's pretty much only used in hydraulic fracturing, and that's the way in which you make the fluid able to carry more proppant, more sand to hold the fracture open.
Okay. And then you talked about our wells being much more shallow than, say, on the East Coast.
Or
And,
Texas.
yes,
They don't call themselves East Coast.
okay. Can you tell me the proximity in the San Joaquin Valley to the water tables, which you said, I thought you said were kind of scarce in proximity to where we think the oil is?
Yeah, so I can tell you that SB4, because it's requiring a water monitoring plan, is beginning to resolve these issues. So for example, one operator applied for permission to frack and had to come up with a water plan, went to the water board said, you don't need a water monitoring plan because there's no usable groundwater here. So just to be clear, that situation is probably common. In volume 2, we're looking in detail at what the USGS data has for the fresh water, that's mapped fresh water, and we are going to be able to compare where, on some scale, maybe not on a very detailed scale, but where you would want to drill down a little bit farther because it shows fresh water in the vicinity. And then you want to look a little closer than, say, the 5-kilometer scale. So I think what we know now is that we can't rule out problems, but probably a lot of these wells don't have problems.
Okay, well, that's encouraging. And then lastly, with respect to seismic issues, you seem to have come to the conclusion that with California having a significant incidence of seismic activity, there's really nothing pointing to the fact that these techniques are in any way contributing to that higher frequency.
Right. Well, one would want to be careful not to conduct an injection or of any type into a known large-scale active fault. I mean, certainly would not like to hydrofracture in the San Andreas. But absent that, assuming that you've characterized the situation enough to know that you're not doing something that's clearly foolhardy, then we haven't been seeing any evidence. We didn't find any evidence so far of correlation in the literature. No one had found a correlation between earthquakes and injection. In the areas such as Kansas and Ohio that are achieving this, the injection depths are much larger than in California. They're injecting deeper. So there's some thought that they're near what they call basement faults, and that's part of the reason that they're getting earthquakes. But we have seismicity in California at all depths, not just deep, but all over the place. We've got it in spades. So it doesn't completely explain why we haven't seen it, but it's going to take a detailed study with in specific regions where we actually get very, very good injection data over time and very good characterization and good detailed seismic records to be able to tell. We're not going to be able to do more without that.
And in your investigations, have you seen any evidence in any studies that shows that there has been any groundwater contamination as a result of some of these advanced techniques? As
a result of well stimulation technology, I think no, we haven't found, in the BLM report, we did not find anything. What we find in volume 2, I can't talk to you about right now.
Okay. Because I believe when you look at New York and their regulations, they propose some rather stringent regulations, yet there was never any evidence of any groundwater contamination.
Right.
So, as a elected official that certainly wants to protect the environment, I also want to keep the jobs and the opportunities here in California, and I want to make sure that our science is transparent and accurate, and I think you've done a very good job today of illustrating the process. And from somebody that didn't know a whole lot about it, you educated me a lot today, and I want to thank you for that.
Thank you.
Senator Jackson?
Thank you. I have a couple questions for you. I know early on, the information that we got about hydraulic fracturing came from self-reporting. Always a nerve-wracking kind of notion that we have to rely on the largesse and the goodwill and the honesty of all our people. Well, I'm sure most of them are, it can skew the results. So I'm wondering, where did your data come from? Was it based on self-reporting, or how did you go about collecting that information?
In Volume 1, there are at least 5 different sources of data, including Frac Focus, Dogger Records, the South Coast Air Quality District records, and several others. And one of the things that you'll find in that study is an evaluation of how much these various sources of data agree with each other. And we found a lot of agreement between these various sources of data. So you can have some amount of confidence that we have an accurate understanding, if not a precise understanding, of certain aspects of well stimulation, like how much is actually going on and how much water is being used. I think those things we have, over time, the numbers may change a little bit, but I don't think we're going to see that the amount of water is going to change from, say, around, 400 million gallons total to 4 billion. I mean, it's just not, these are numbers that are holding up over the year and are holding up across different databases.
So can you tell how much water approximately is being used for? Yes.
Yes, we have a number on that. It's between 150 and 400 million gallons per year total for hydraulic fracturing, which is a very, very small amount. And, you should also, to really understand this, and I also would like to compliment you on, I believe it's 1281, SB 1281, that's going to keep track of water, because the water question in the whole oil industry is something that needs to be looked at it shouldn't just be looked at how much water we use in hydraulic fracturing, because each of these wells also produces 90% water, and that water, some of that water can be water supply. Some of it needs to go back into the reservoir to maintain pressure. Some of it has to be disposed of, but some of it can be water supply. And so understanding that whole picture, including what's happening in reservoirs that are being steam flooded or water flooded, is probably important to California.
So how do we measure or determine the quality of the water that comes up, the produced water or the water that comes up from injecting? Who determines whether it's drinkable water or whether it's carcinogenic water? How does that?
That's one of the issues that we identified in the BLM report as something that needed more attention. So right now, as far as I understand, if water is going to go from an oil, from the oil well where it's produced into agriculture, it needs to be tested, and it's tested for salinity, for boron, for radioactive materials, but it's not tested for any chemicals that would be used in hydraulic fracturing. And so the amount of treatment that it receives that it can receive is studied in Volume 2. You'll see a good assessment of that. There are treatment protocols that are being developed right now that will address hydraulic fracturing fluids. They're complicated, again, because of all the different chemicals that are used.
Jonathan Bishop can also answer these questions from the State Water Board.
Okay, so yeah, you'll hear more about that. But there will be an assessment of that in Volume 2. And I think basically one of the issues, but I just reemphasize, one of the issues we saw is that we think it's possible for water that from wells that have been hydraulically fractured to be getting into agriculture, and we don't see testing protocols in place.
So who is going to do the testing? Is it going to be sort of like self-reporting?
I think that I can't answer. I'm sure Jonathan
Sounds
Bishop
like
can
a
address.
bill, Senator
Sounds like,
Jackson.
well, sounds certainly a curiosity that deserves to be pursued.
Yes.
And my last curiosity deals with the fact that today in the LA Times, it's reported that there were high levels of benzene found in fracking wastewater. Would you address that issue?
So, I mean, one of the things that's happened with SB4 is that we have a lot of information about hydraulic fracturing, but again, we don't have a lot of information about things that are not hydraulic fracturing. So benzene is a chemical that is normally found in oil that's produced. So the benzene is not commonly used, to my knowledge, in hydraulic fracturing. So it's likely that the benzene, the source of the benzene, is actually from the oil reservoir itself, from the water contact with the water being mixed with oil when it moves.
Which happens when you frack, correct? I mean, it's not necessarily in the fracking material, but what comes up is oil.
Right.
And that contains benzene, and that's a carcinogen, is it not?
Right, and the water that's produced in any oil reservoir in California with any technology may have the same condition.
Which isn't good whether it's from fracked water or other water,
Right.
but if it's in our drinking water, it's benzene, and
That's
that's a
not good.
carcinogen. Okay.
That's not good.
Last question, I apologize. The water that's used for fracking, that's injected into the ground before any water, additional water comes out, where does that water come from?
A lot of it comes from the regional water supply. Some of it's reused. And increasingly, companies have been trying to recycle or reuse their produced water. It's more complicated for them to do that because of all the water isn't pure, so that controlling the chemistry of the frac fluids is a little bit harder, but they are increasingly doing that.
Thank you.
An additional question?
Madam Chair, the process of injecting the water for the oil production in the Central Valley, is this by the same mechanism that is used in geothermal wells, if you will?
To do hydraulic fracturing in
Yes.
geothermal wells? Yes, it's very similar.
Very similar.
Yeah.
Thank you very much.
Right. I want to thank you for your testimony and just follow up for my own personal clarification. When you're determining where aquifers are or underground streams and lakes, is that, you're determining it just once? Is that something that needs to be ongoing? Because I'm thinking third or fourth year of record drought and a possibility of, in rainy years, hopefully we will see them again, that water table is going to be expanding, and how you map it now may not be relevant 10 years from now?
So the concept of underground lakes and streams are not something that hydrologists generally talk about. We talk about aquifers.
Right.
So if you think of just a simple geologic situation where you have layers of rock, and where the rock is more porous, more permeable, there's more space between the grains, then that can have fresh water in it that can be pumped out and used for water supply. The water, usually as you get deeper, the water becomes more saline and, yes, less usable. And as well as you know, the water table is the point at which in the rock where the pores are filled with water and don't have air and water. Above that, they have air and water. So at the point, as California mines water, essentially,
Well, we're overpumping
we
our
overpump
aquifers.
it. The water table drops. So the water table is, again, the pores then will be filled with more and more air, and you can't pump it out. So the situation is that the geology doesn't change, but what can happen over time as you pump more water is that you not only lower the water table, but because the water pressure isn't there to hold everything open, it also collapses.
Subsidence, right.
So the condition of the actual fact that the reservoir is there, the aquifer is there, wouldn't change, but the condition of that aquifer can change. And it could also be invaded by salt water, especially along the coast, where you pump water from these aquifers and then you have seawater invasion, seawater moves in. So it's not that the location of them would change, but their condition would change. And so you do have to have monitoring besides.
We all tend to agree that staying away from earthquake faults and sensitive groundwater basins or water supply is important. So thank you for that answer on whether it's a moving target at all. And You had mentioned that there's so many different chemicals, but I wasn't sure if you were implying that there's some unknown volatility in certain combinations of chemicals.
So when we have,
Is this a data gap issue?
yes, it's a data gap issue. So there's probably at least 400 chemicals that are being commonly used in California, some more than others. Of those chemicals, when those chemicals are pumped down into the ground, they react with each other, they react with the rock, they react with water, and then you bring all that water back up. It's concentrated in a soup of things that you sent down and things that reacted when they were down there. And that is commonly called flowback water, but there's no point at which you get it all back out. And so you can take some period of time until you start producing the well, until you start getting oil out of the well and put it into production. That period we're calling recovered water, and that's usually stuff that you need to dispose of. You're not going to put it in agriculture. But over time, the water that you pump out of the reservoir, along with the oil, will become less and less concentrated in these chemicals. But they're very difficult to characterize because we have so many different kinds of chemicals and so many different kinds of reactions possible. So it's a problem that gets more and more complicated. So if you had, 2 chemicals, they could react with each other. If you have 4, you can have each one react with each other one. And when you have 400, it's overwhelming. It's overwhelming to understand the entire chemistry of this process. So just to give you an example, in Pennsylvania, we're developing a protocol for the Center for Sustainable Shale Gas Development is developing a protocol for treating wastewater so that it can be used and disposed of in the environment or released to the environment. And we're developing an integrative test to see if that effluent as a whole is toxic, because you can't go after each chemical. So you treat it, you have tertiary treatment, and then you take what comes out, the effluent, which is very pure, and develop a protocol for testing that to see if it's toxic. Because going after every one of these chemicals is overwhelming. You can't do it.
All right, I guess, thank you for that information on, and I don't understand the interaction, but I want to make sure the protocols are in place and someone is monitoring, especially for reusing any of the produced water for agricultural or other purposes, and how it mixes in with the benzene that could be naturally occurring in the oil anyway. And so
It's a good question.
well, more complicated than I thought. So thank you again, Dr. Long. Thank you, Dr. Mace. Excellent overview. We look forward to perhaps hearing from you again post volume 2, 3.
See you in July.
All right.
Thank you.
All right, let's move on to our second panel. This is regulatory implementation. We have with us from the Department of Conservation, Dr. Mark Nekadam, he's the director, and Dr. Stephen, is it Bolin? Bolin. I wanted to say that, but I just didn't quite get it right. He's the oil and gas supervisor in the Division of Oil, Gas, and Geothermal Recovery. And, is this we're all going together here? That's fine, yes.
It's a symbol of our increasing cooperation.
Well, this was part of the memorandum of agreement that you will spend lots of time together and making sure that we're protecting water supply during this process. So that works well. Okay, so Dr. Nekadam, are you
Indeed,
starting off?
thank you, Chair Pavley, senators, and members of the public. I actually very much look forward to this hearing today. I think we've all shared some very interesting history over the last 3 years, and we have come quite a long ways, not just in terms of working with our colleagues at the Water Board, but in many things. I wanted to just recall over the last 3 years the increasing focus. You did mention your letter from January 2011. I was appointed in January 2012, and when I reviewed that letter with my staff, I thought certainly we could have done a much better job of accurately answering that. And I think over the last 3 years, we certainly have. When I got here, it became quite apparent that hydraulic fracture stimulation and other well stimulation was a very high priority among several issues in the Division of Oil, Gas, and Geothermal that we wanted to tackle. And within just a few weeks of our first budget hearings, we started having a series of listening sessions and workshops around the state. At those workshops, we produced, discussed a discussion draft of a draft regulation for hydraulic fracturing. And that had been on the street for several months until you, Senator, picked up the ball and ran with SB 4. And I think that ended up being a much more appropriate strategy given the breadth of what we needed to accomplish. We, in the interim then, have had over 27 different workshops and public hearings on well stimulation in the last 3 years, and precisely this week and next, we will be having 6 more hearings on the environmental impact report. Those are happening around the state. Our hearings and our public workshops and meetings have happened in more than 11 cities, and I think we heard pretty much the entire span of public concern about hydraulic fracturing. It was quite intentional. We wanted to get in front of the public and in front of the issue and make sure we had a full understanding of the complexity of the issue in the public's eye. Then we come to SB 4, and I think we will recall that in the development of that legislation, we had a number of conversations about the panoply of issues that Dr. Bolin will go through, one of which, of course, was neighbor notification and our collaborative work with our other agencies. I think Dr. Long's presentation just put a fine point on the issue that our authorities within one department certainly don't cover the span of media that hydraulic fracturing, well stimulation, and oil and gas operations can actually touch. And I think it is very important that we now have a far more complex and thorough working collegial relationship with our sibling agencies. So in the time since SB 4 was passed, and it was signed by the governor in September 2013, we put in, as per SB 4, interim regulations that were in effect January 1, 2014, that covered almost all of the aspects of what are in the permanent regulations, and Steve Bolin will go into that in some detail. The final regulations were completed on time. In fact, I think with the exception of the CCST study, every deadline has been met for SB 4 as specified, and that simply, I'm sure they will confirm, was because of the peer review process and necessarily differing volumes 2, 3, and now I hear 4, which is great. We also have released on January 14th of this year the EIR. We have a 62-day review period. It's about as long as we could fit in order to allow the public to comment and in order to allow us to review all of the comments. If it's anything like our regulations, on which we had 140,000 comments, written comments, it'll take some time to go through all the comments and respond to them. I'm going to turn over any further detail to Dr. Bolin. I will say, though, it's been a great asset and pleasure to have Steve with us. He was appointed by the governor on June 2nd last year. Therefore, he's 8 months in the hot seat, and we're not only enjoying him, but he brings an enormous amount of scientific expertise to the division. He comes from Lawrence Livermore National Labs, where his primary focus was on nuclear safety, including seismicity. He was also the head of all the science programs at the U.S. Geological Survey, and therefore, it's a pleasure to have a fellow scientist with me at the helm. So I'll turn it over to you, Steve.
Thank